YouTube. Today we're going to be learning about impulse. So, what you're going to learn today is how can you stop this wall from breaking and protect the driver when someone drives into your house or drives into your fence or stone wall. So we're going to learn about how to prevent damage and collisions. A little reminder, objects with more momentum give more damage and take less damage themselves. We're going to talk about how to reduce that momentum today. So here's the answer for number 1 in your note sheet, is the impulse formula. Another way to think about impulse is impact. So impulse is like the science term. Impact is like what you use in your common vernacular, common language. Here's the answer for the formula. Now I want you to pause the video now. Where have you seen another formula with 2 equal signs? Specifically from the last unit. And you may think, oh, the work formula. That's right, yes, the work formula also had 2 equal signs. So if they have 2 equal signs, that means there's 2 different ways to get impulse. And that can also make it tricky. So sometimes you will only be able to solve it one way when there's usually 2 ways to find impulse. And just a reminder, instead of I being for impulse, I is already taken its inertia, so they use J for impulse. And then impulse is force times time, force times change in time, and that is equal to the change in momentum of an object. The units are newtons times seconds, or the units for momentum. So there's 2 different options for units. Yep, and then please answer number 1 and 2 in your notes. And then for number 3, we would have watched this video from Professor Dave about impulse, but you can skip number 3 because we're not going to be able to watch the video because of YouTube copyright. Next, here is the practice problem for Spider-Man. A typical train has a momentum of 290,000 kg times ms. If his webs can handle a force of 2,500 newtons before they break, how long will it take Spider-Man to stop the train? So we have the change in momentum, 290,000 kilograms times meter per second, and the force that his webs can handle is 2,500. So using the formula, this formula, how can we find how long it will take Spider-Man to stop the train? I'll give you a hint. The J is actually not often needed. Unless the question is what is the impulse, you really don't need the J, so just focus on these 2 to solve how long it'll take Spider-Man to stop the train. Okay, and part B, if the train is going 40 meters per second and the pier is 4,000 meters away, will he stop the train in time? So please pause the video now and try and solve this yourself. Okay? And now we're going to go over the answer. So for the first one, you'll need this formula. Force times time is change in momentum. And Spider-Man has to stop the train, and the train starts with 290,000, so the change in momentum is 290,000. The force is 2,500, and we don't know the time. So you'll do some algebra. The time is 290,000 divided by 2,500, and you should get 116 seconds. So that's how long it will take Spider-Man to stop the train. Well, how long will it take the train to get to the pier if the train is going 40 meters per second? For this one, we'll need an old formula. There are a couple ways to solve it. The way I did is speed is distance divided by time. The speed is 40 meters per second. The distance is 4,000 divided by time, or t. Now, you may have not seen this very often. If t is on the bottom in the denominator, we need to get it on the top. So we will times both sides by t, so we'll end up with 40t equals 4,000. So all we did was multiply both sides by t. That canceled out the t's on the right, so we end up with 40t equals 4,000. Divide by 40, you'll get t equals 100 seconds. So I want you to think about it. If it takes him 116 seconds to stop the train, and 100 seconds for the train to hit the end of the pier, he won't stop it in time. And if you watch this clip, you'll see why. You'll see that you were right. So, because of copyright, we can't play the audio, or else you'll get it flagged on YouTube. So, but I do recommend this movie. It's known as one of the best superhero movies of all time. Spider-Man 2. So he's using his webs right now to slow down the train. I know you may have thought Tom Holland, but this is the original Spider-Man. Tobey Maguire. And I just fast-forwarded. As you can see, it's really tough to stop the train. It's taking a lot out of him. Yeah, I'm sorry. My nanny isn't able to come tomorrow, so I had to take the day off. So otherwise, you would have been able to enjoy this audio. But yes, okay. So you just saw the train hit the pier, so he didn't stop it before it went to the end. But thankfully, if you keep watching, despite making it past the end of the pier, the train is slowing down enough to save all the passengers. Okay, moving on. So, the answer for part C, the easiest way to reduce impact from collisions is to slow the object down. Okay, next one. I want you to pause the video now. Can you talk with the person next to you? Why should you catch a water balloon like this? Why is this good technique? Talk with the person next to you, pause the video. Why should you catch a water balloon like that? And the impulse formula will explain why. So, this is me in 2016. We did a water balloon throw competition, and my brother and I won because of that great technique. So, when you catch it like that, you give it a lot of time to stop. So, if you increase the time, if you look back at the formula, if the change in impulse, the change in momentum is the same, but if you increase the time, the force has to decrease to compensate for the increase in time. So when you catch the water balloon really slowly, it reduces the amount of force. Versus if a water balloon hits the ground, it'll stop really fast and probably break. So here's the question for you. If the balloon has a momentum of 30 kilograms times meter per second, if it takes Mr. King 1.2 seconds to stop the water balloon, how much force does the water balloon experience? And if I miss it and it hits me in the face, the water balloon stops in 0.5 seconds. How much force does the water balloon have then? Okay? Pause the video now and try and solve it. On the next slide, I'll go over the answer. So we're just using that same formula that we did previously. Force times time equals delta P, or change in momentum. So the balloon starts with 30 and it'll stop, so the change in momentum is 30. We don't have the force, but we know the time. So you'll divide 30 divided by 1.2, and you should get 25 newtons. So it may not be enough for the balloon to break, but if the balloon stops in 0.5 seconds, then let's see what will happen to the force now. So the balloon still has 30 momentum, but this time you stop it in 0.5 seconds because it hits your face. You aren't able to bring it in slowly. And then if you divide 30 by 0.5, you will get the force is 60 newtons, and that will be enough to break the water balloon. So that's the answer for B. Answer for A was 25. Okay, next we're going to have an advanced problem. This is a tough one. This is like a question you would get in AP Physics. Deadpool weighs 60 kilograms. If he has a momentum of 2,000 kilograms times meters per second, how fast is he moving? And if his parachute provides a frictional force of negative 50 newtons over 30 seconds, how fast is Deadpool moving at the end? So I'm going to give you some time, pause the video now. Can you use your momentum formulas to solve this one? And here's my hint. So remember the first formula we learned in this unit, P equals m times v. If you rearrange the formula, the velocity is the momentum divided by the mass. 2,000 divided by 60, Deadpool is moving 33.3 meters per second. And then you'll need the new formula for part B. So, to get the change in momentum, you do negative 50 times 30, and you'll get negative 1,500. So this is the change in momentum. If Deadpool starts with 2,000, and he loses negative 1,500, then at the end, he only has 500 left, because you do 2,000 minus 1,500. So 2,000 minus 1,500 is 500, and then you'll plug it back in to the equation, momentum equals mass times velocity. If you divide by 60, you'll get 8.3. You could also do it this way. If the change in momentum is negative 1,500 and change in momentum is mass times change in velocity, and you solve for the change in velocity, you'll get negative 25. So he slows down by 25, you do his initial speed minus 25, and you'll still get 8.3. So you could have solved it using m delta v or change in momentum this way. A couple ways to solve it. You should have ended up with 8.3. I think the easier way is to do 2,000 minus 1,500 and then plug it back into the P equals m times v equation. That is the last thing before the egg drop. But I just want you to remember while we do this, there's two ways to protect your egg in the egg drop. One is slowing the object down. Two is increasing the time it takes to stop. Less impact if you give the object more time to slow down and stop. And that, in this case, would be packaging. If you have packaging, it'll give the egg more time to roll around and reduce the impact. So what you're doing for the rest of the day is preparing something to protect your egg from a 3-story drop. You can use straws, strings, pencil, tape, paper, and cups. You can't use a plastic bag. It would be too easy. You have to make the parachute yourself using paper and tape and the other materials listed here. Good luck.